right, let's get started. Let's get started. All right, so today we'll talk about email. We've started on the email homework, I hope, but that's only sort of a small part. I think I can turn off the lectern mic now. Okay. It's only a small part of the whole sort of email infrastructure ecosystem sort of thing. So I thought we'll take a good look at many of the various pieces of email. Yeah?
Where do we submit?
Ooh, that is a very good question. Yeah, I will update the homework description. It'll be through GitHub Classroom.
Okay.
Yeah, but I forgot to put the invitation link. Thank you. Let's see if I can change the light here. Oh yeah, okay. All right, so email. Yeah, so just as a reminder, the homework is due on Friday at the beginning of class. Hamed has office hours tomorrow as well, I think, if you need any help with debugging and such. I made my own little solution to this. I think the main thing you need to keep in mind is the email server is kind of picky about exact syntax, right? So you got to have spaces where you have to have spaces and no spaces where you don't have to have spaces, and always end every line with \r\n. One thing that I found really handy, you're also listening for responses from the server. Some servers might be a little more verbose than others, and it gets hard to get everything quite right. But one thing that the servers always do at the end is they say a status code and then some message. So there might be some other blabber before, but then there's a status code and a message. So you can always just look for that. That's what I did. I just keep fscanfing after for new stuff from the server until there's one of those numbers. The first word on the final line is a number that says how it's doing, and you don't need to worry about the text. You can just see, oh, what's the response? Hey, 250. That means we're good to go. Let's send the next command. Was it something other than 250? Probably an error. Maybe you want to handle that, depending. I think for the data it was not something other than 250. It was like 437 or something. So just check for that, and that should be fine. So I wrote one little function that is like a send command function, because it's the same for every command, so I can reuse that. And then I had one little function for a receive response, and that just gives me the code back. Right? Maybe print some debug stuff sometimes, but basically just gives me the code back so I can use that in my program logic. That way the program is really short. It's like that. Okay, any other questions on the homework before we get going on this? Right, so I would say email, it's a very large distributed system. There's different kind of application models out there. You have your standalone applications like this program here, which basically is just on this machine, nothing else going on. Then you have your client-server programs, where there's a single server that everyone talks to coordinate something. So let's say a database might be like that. You can think of the World Wide Web as that. All right? When you're talking to just one server, usually it's a client-server sort of mode, but most web pages incorporate stuff from all over the place, and then suddenly it's a distributed system. Email is definitely a distributed system. So we have our mail, I think they're called mail transport agent, mail transit agent, MTA. They speak SMTP, right? The simple mail transfer protocol. So that's what we've been practicing. Basically, they're all like that. All the delivery servers for email speak SMTP. So we're usually the mode of operation is something like this. Let's see. So it's this one. So we have our email client. Let's not use circles. Okay, that'll work. So we have our email client. Who here uses an email client? And who uses some sort of web Google thing? Okay, about half and half. All right, so whatever you talk to, when you want to use Gmail or Hotmail or what are the good ones? I don't know. I guess Gmail's sort of taking over. Outlook, maybe? Yeah.
Is a like standard like mail app on the phone a traditional
Yep,
mail client?
that's a traditional mail client. Yeah. So when you have a piece of software that's running on your device, whatever that device is, that would be an email client. When you're sending email, oh, and let me put this here. You might have a web-based email client. This would be Gmail and many others. Right. So you want to send an email out. That's you're contacting your local SMTP server. So this is the local mail delivery agent. So we're sending the email. I'm going to ignore this web-based because usually that's a little more centralized. But essentially, it works the same way. Where are the arrows? There. Right. Can we grow this to? Yeah. Okay. Well, hide. Good. Okay. So from the email client, you type in your email, you hit send. The message goes to your local SMTP server over SMTP. And here you're talking, oftentimes you will have an authenticated connection here. So this is not like the SMTP that we've been using. First, there's a little login process, username and a password or something like that. Or the server might check that, oh yeah, they're already on my local network, and so they're okay to talk to me. No one else is allowed, right? So a couple of different authentication options. They may also be encrypted. I think the encryption could be SSL encrypted. I believe it's SSL, but not 100% sure of that one. So basically your connection between the email client and the local SMTP server, which could be not local. It could be, so if I'm at home, hold on. If I'm at home and I'm sending a UIC email, I'm still connecting to the UIC server. I'm authenticating with a username and password so they know it's me. But that whole thing is encrypted so that my neighbors, when I'm using an open access point, don't get to see my email. Yes?
So when I was like Googling around, I found OpenSSL, and you could like contact Gmail through that and then have like encryption. Is that kind of what you're talking about?
Yeah, OpenSSL is one implementation of SSL, a secure sockets layer. We'll talk about that a little bit more when we get to the web. But basically, it's just an encrypted socket. You connect to the other side, there's a little bit of authentication, and then anything you send after that cannot be seen by others other than as encrypted text. That's not useful to them. Okay, so we connect over here. Usually it'll be report 25, and this is often encrypted and often safe. No one can trick this server. Okay, and then in a simple scenario, it would go to the destination SMTP server. Let's see. All right, so this part is what we're implementing in our homework, really. We're not doing this thing, although it's quite similar. We're saying this local SMTP server takes all email. Like, you can send it to any destination and it'll just say, okay, fine, I'll handle it. That's really handy because if you are on your laptop, you want to send an email and then you want to close your laptop and go away. Now this local mail agent, the SMTP server, it'll receive your email, keep it stored on their end, and then eventually get it transmitted to the other side. because it's not entirely obvious that this SMTP server is available at the moment. Or maybe this link here, actually we should draw this with the traditional cloud. Do we have a cloud? We don't have a cloud. We used to have a cloud. Here, okay. Come on, all right. Okay, so our link to the destination SMTP server goes through the internet, right? We don't know how fast this link is. We don't know how fast this link is, or lots of stuff in between. Sometimes they don't work, like that. So you want to send an email and then leave, and hopefully you have a reliable connection to your local server, and then it can handle the eventual delivery, much like the postman, right? Okay, so that's the sort of point of that. That's why we're not connecting straight to here, because if it's a slow link, it's better that a local server handles it for us. Yeah?
Who runs the local server?
That would be usually the administrator of your email domain. So if you are using a Google address, it's Google. If you're using a UIC address, it's UIC, and so on. So generally speaking, this server will take outgoing email to any destination address, but it'll only take email from its own domain. Right? So if you claim to be from UIC, that's fine for a UIC server, and it'll deliver it. But if you say, yeah, I'm Jacob at Google, then this server will decline it because they don't service Google addresses. Okay, so yeah.
If, let's say, we're using UIC and I'm a UIC student, I'm sending to another UIC student, does this still have to go to the, like, all the way to the destination?
The remote destination server could be the same one, or it could be, so I mean the destination server is also UIC, right? So it's sitting right here.
So it doesn't have to go through the entire internet?
No, although the entire internet is usually pretty abstract, it could be as simple as one link. Right? It's just that we don't really know, and usually that's the sort of the abstraction that the internet provides. You give it a destination address, IP address, and then you don't care about the rest. It's just going to get there.
Okay.
So it could be that UIC keeps two servers, one for outgoing email and then one for incoming, and they do the transmission between like that. Or it could be it's the same machine. Yeah.
And web-based client works the same?
A web-based client works the same, except then it looks like this. Oh, no, it doesn't. Right. So your web browser is talking to the email web client, right? And then this one then talks to their local SMTP server. Usually the way it goes is you would be using any browser to talk to gmail.com's web server, which talks to Gmail's SMTP server. It'd be unusual for you to use the Gmail web client to send a UIC email, but I think they support it. Like you can add another email address or UIC email address to your Gmail account if you want. In any case, this is sort of just a virtualized version of this in some sense, right, or a webified version of an email client. Okay, I'll just remove that now. Okay, so in the end, a file, much like the one that we're dealing with, right, is, well, maybe it wasn't really in existence here. Once it's delivered to here, it shows up on disk on that email server. It's just stored, okay, this is a file I need to deliver. It'll look much like the one that we sent. Maybe it's got some more timestamps and that sort of thing in it, and some path where it came from. There's some extra details, but nothing really important. And then there will be a local server process on the other side that looks, or on this side, that looks very much like the homework that we're doing, that reads through all these files and then tries to deliver it to the destination SMTP server. It finds this through the DNS system. I really should change. Oh, no. Okay. The domain name system is kind of helping out in figuring out which one is the destination server. So here we have foobar.com, and here's foo.com. All right, so this local server, and this might be called smtp.foo.com. That's the outgoing one, and maybe this one is called incoming.foobar.com. So this MX record, and we'll see the domain name system in more detail later, but basically there's a big, huge lookup table, that's the DNS, that says, oh, the MX entry for the domain foobar.com, because we were sending to Jacob at foobar.com, is incoming.foobar.com, and then we will contact the destination SMTP server, and it ends up as a file on this destination SMTP server. All right, but now we want to read our email, right? So we have another email client on the other end. Is that going to be my default now? That's great. Wonder if I can. Yeah, it is the default. Damn it. There's some trick to this, but I keep forgetting. Like that. All right, we'll see how it goes. Okay, so here is my email client again. But now I want to fetch any email from my inbox. If you're using a normal email client, this is familiar, right? It says checking email, it's contacting a server to get it, but SMTP doesn't support this. The original way that we would use email is you log in, not with SSH, with Telnet at the time. You would log into the server, much like and then you would run my mail client. In fact, I don't have any mail clients installed on this, and I don't know if mail is one. There used to be a command line mail client. I forget the names of these, but they would just basically read the files from the local disk. Right? So the SMTP delivers these files to a local disk. I run a program here. I have permissions to read those files, and so now I can see my email. Can anyone remember a name for a command line email client? Mutt. Yeah, that's right. I used to hate that one. What's the other one?
You can straight up send mail if you want to.
Straight up send mail, yeah. That's not. Let's see. Yeah, Mutt is not installed either. Okay. In any case, that's not what we do anymore because it's kind of a pain to use these text-based email viewers. Yeah.
If it was just delivering files locally, what was the difference between that and like FTP?
It's really convenient to be able to say like, oh, deliver to this user at this server and forget it, right? And it writes to a specialized folder for email, right? But it kind of does it without having permissions to write to it. It's just an incoming folder where anyone can append new files. So it's quite different from email in that sense. Oh, sorry, from FTP in that sense. Although there used to be this kind of anonymous upload folder oftentimes on FTP servers. So if you were to follow a very strict protocol, like some agreed upon thing between users, I would say it gets quite similar. Right? I think the integration with the domain name system is probably also a nice boon to it. In any case, there's all sorts of other protocol too, right? How you format emails so that they look nice when you read them, and how you make attachments and all these things. In any case, now I want to read email from a remote server. This stuff is sitting on disk, looking much like the little email files that we have in our homework, but I want to read them. Maybe I could use an FTP client. Probably could, kind of, but it'd be a pain. It'd be really complicated. A nice other solution is I have. Oh man, this is gonna get annoying. Is there a? Okay, so now we have an incoming, I'll just call it an IMAP or a POP3 email server. Okay, so this is for reading incoming email. They usually share a disk. Right? So there would be a shared file system here. The SMTP server just delivers all these files into some folders. And then you have either an IMAP or a POP3 server, IMAP being the more modern, advanced protocol. They're essentially the same thing. And the email client will connect here over IMAP or POP3 protocol to ask if there's any new email, right? Or get a list of all the emails sitting in the folder, or get, there's as you know, all sorts of stuff you can do with emails, right? Delete them and so on. So to fetch email, we use this protocol, and to send email, we use this protocol. But I think the most important thing to realize about email is that this thing here is often encrypted and authenticated. There's no faking it. This part here is virtually always authenticated. It would be pretty stupid for it not to be encrypted. This is where you're reading your email. It'd be nice if some random person can't just come and read your email. But this part here is entirely unencrypted. Let's see. What can we do? Unencrypted and unauthenticated. Right. By encrypted, I mean that if someone was to see the traffic, let's say your internet service provider, you're talking to Google, you're sending an email. If they observe that email flying past, they can actually read the text of the email that's unencrypted. If it's encrypted, like with HTTPS, this SSL encryption over here, or any other kind of encryption, it just looks like gibberish. But if it's unencrypted, which it is with SMTP, it's perfectly readable if you have access to the traffic. So basically, you need to either have a wireless connection, like these users. From here, it's going over a wireless connection and someone's listening in. And that's an unencrypted wireless connection. Or you're in control of the systems that provide the service. So if it's your wireless access point that someone else is using, you can listen in on their traffic. Or if you are the internet service provider and you're selling connection to your customer, you can read your customer's email. Or if you're a hacker and you happen to have access to any of the systems along the way, the various routers, then you can read all that email like a postcard. By unauthenticated, I mean that anyone can pretend to be foo.com, right? And we've seen that. So you can send email from the president, and because it's not authenticated, we don't need his username and password, right? We just claim to be him, and that's that. And that's just in the nature of email. This has led to some problems. I think the main problem is spam. It's not that common that someone sends a fake email. It doesn't go that far. If I get an email from Donald Trump, I might probably at least ask him one way or another if that was right. I might send a response back, like, "Are you sure you want that?" And then it doesn't get delivered, or they're asking, "What are you talking about?" That sort of thing. Because when I respond, it's going to go to president@whitehouse.gov. Now, I don't know if that's his email address, but so it's hard to fake it really well. And it looks right, but then you can't really use it that much. It's pretty handy if you want someone's, say, bank passwords, right? Because then you can send an email saying, oh, this is Citibank, make the email look very much like Citibank. And you say, yeah, please log in and update your home address or whatever. And the link goes to something that isn't Citibank, right? And then if you're not paying attention, this is called phishing. If you're not paying attention, you'll type in your name and password, and now they have it, and they can do what they want with it. This is why you probably want to pay attention when you're clicking on links in email, because anyone could have sent it. You can't really trust it. And of course, don't send any sensitive information over email, because everyone nearby can see it, essentially. Okay. Another problem that's probably bigger, I think, is spam. All right. So Actually, I think spam has gotten a little better lately. But it used to be I would have 50 or so emails a day from just random senders that had nothing to do with me. And I would have to delete those. But sometimes, honestly, it tends to be grad students or potential grad students who are wanting to know about admission possibilities and so on at UIC, but most of them are just like some dude from Nigeria who wants to have help transferring $1 billion, that sort of thing. And usually those are not authentic. And so this spam problem is directly related to the fact that anyone can send email to me, right? There's no permissions. Oh yeah, that's not even here. There's no permissions required in order to send an email to me. Facebook is different, right? If I want to send a message to someone, I have to be friends with them on Facebook. So you don't get spam on Facebook, almost. There's some exceptions to that. All right, so it's permission-free. It's unauthenticated, so anyone can send the email claiming to be from anywhere. The unencrypted probably doesn't matter in this case. And it doesn't cost anything either, right? If it cost, say, 1 cent to send an email to me, I would have gotten much less email in the past. Now there's a bunch of different measures that are in place to try to reduce the amount of spam. We'll kind of take a brief look at those. Yeah.
Why did you get whitelisted that one time? And what does that mean? And what was the TP server?
Oh yeah, so that was one anti-spam countermeasure. It's pretty simple, but yeah, we'll get to that in a little bit. Yeah. All right, but so this is like without worrying about all the various threats. This is the way it's set up. This maybe is worrying a little bit about threats, and here this being encrypted, that worries a little bit about threats that you can't delete and access other people's emails. But overall, it's just kind of a naive setup. The main threat, yeah.
I'm just kind of confused on where is the local SMTP server. You said it's like UIC.edu or gmail.com. So it's like, so right now if I open my phone and then try to send an email to someone at gmail.com, so my connection between me and UIC.edu is secured with SSL. Is that
Yeah, most likely.
But when UIC and SMTP server sending it to gmail.com, that part is not encrypted.
Right.
Okay.
So from your email client on your phone, you send the email to here, encrypted. Then this one looks up the Gmail incoming mail server. So it sends the unencrypted email over here, gets delivered here, and then the destination person at some point checks their email, which pulls the email here over an encrypted link again to get it finally.
But I just thought you mentioned that if somebody has your wireless access point and stuff like that, they can hijack the email.
Not on this part, if
Okay.
this link is encrypted, which it often is. Not on this part if it's encrypted, but there's also this part, and that can also be wireless. So if that part is wireless, then it's over. Or anyone who happens to be sitting along the way, all the routers along the way have perfect accessibility to all that email.
Okay.
I guess that's not quite true. I mean, yeah, in general, it is plain text, but oftentimes you find that maybe you only get some of the email because packets go many different paths, and so you might have a hard time assembling the entire email just out of bad luck. But there isn't really a security thing in place there. All right, so the main threat that we've tried to counter so far, I would say probably, is spam. And then maybe the other one is the spoofed emails from an inauthentic sender, like the way we're doing. You may have encountered some of that. I don't know, did anyone say, or see origin not permitted, anything like that, or sender not permitted? Yeah, with which destination, which source?
It was like the Gmail when I was on my local ISP.
You're on your local ISP, and you're trying to send to Gmail. From which email address?
I think it's from Gmail. I was like trying to send it from myself to myself.
Oh, from Gmail to Gmail.
Yeah.
Yeah. Okay. Yeah, they would definitely not permit that.
Yeah.
Right. So they have Gmail has a good idea of which are the outgoing Gmail email servers, and so now they see, oh, here comes an email. They're pretending to be us. Right? Let's not accept that. And you may encounter something similar if you try to send to a UIC address from a UIC address. I haven't tried that. cs.uic.edu is a separate domain, entirely separately managed, different software, different everything. That's why I've been using those two different domains. Okay, so anyway, how do we manage this thing? There's a few different pieces. Let's worry about spam first, let's say. Or I don't want to call them security measures because they're not really all that secure, but maybe they're like countermeasures against some attacks. Okay, so for spam, usually the idea with spam is you get a list of 100 million email addresses, and you make some outrageous claims, and then you send it to 100 million people. So one easy way to kind of push back on spam is to make it a little bit more work to send spam. And that's the one that we ran into with the UIC, with the CS mail server. This is called gray listing. Delay, let's see. So with gray listing, basically we tell the sender, okay, you can't do it right now, but if you try again in a minute, you can do it. So that seems like a really minor hassle. So we ought to be able to handle that. But if you're sending 100 million emails, and you are some script kiddie or a Nigerian prince, maybe you don't want to be bothered with this. So it's a little bit more work. It's more state keeping. Like now you have maybe 50 million addresses that you need to put in a separate list so that you can try again. You have to remember when you tried last. And, it seems really easy for a computer scientist, but usually people doing spam work are not computer scientists as much as high school hackers. And so maybe that helps a little bit. That's the principle of it. It's not a really efficient scheme. Okay, another one, blacklisting. So this could be either origin domain or IP address. So here we're saying, oh, you're sending from UIC. I'm sorry. We've seen too much spam from UIC, and so we're not accepting any more UIC email. That's it. Right. And this is a relatively common approach. Just refuse email from certain senders. So this is not from a certain user. This is usually from a certain server. Right? So it'll either be this entire domain, some .ru domain, is sending way too much suspicious-looking email, and so we'll just cut it out. What's really nefarious about blacklisting is that usually there's 2 or 3 different organizations that maintain blacklists. So you end up on a blacklist, and then most of the email service in the whole world will refuse your email. And it's really hard to get off it. We've had encounters with this. I don't remember now, but I don't know if it was even UIC. I think even like all of UIC ended up on a blacklist somewhere, and it's really bad. But it's quite efficient in the sense that it's really hard to fake your IP address. So if you have an email server in your home, let's say, and you're using that to send billions of spam messages, pretty soon it'll be discovered that, oh, all these spams are coming from this one IP address. You can't really change the IP address much. And so you end up on the blacklist, and now you can't send it anymore. Unfortunately, it's not efficient if you happen to have access to a botnet, which these people do now. Botnet being millions of infected PCs all over the place, and just anyone's machine. So now they use 1 million different machines to send their email, and you can't really blacklist all those million machines, or if you do, it creates all sorts of problems, and then they just move on to another 1 million machines, and so it's not all that effective anymore. Okay, and then there's, let's see, okay, so there's spam filters. So this is various sort of AI approaches, text mining approaches to detect what is a spam. Of course, you've seen this. If it's got something to do with Nigerian princes, usually the email just disappears. You don't even see the email because either your server deleted it already, there's big products that do this sort of thing, or it shows up in your spam folder on your laptop. Often it's based on keywords or based on sort of patterns in the email. Maybe it's just a picture, there's no text, simple things like this. And the spam filter will just kind of try to reject it, and usually it works pretty well. The main thing a good spam filter does is see, did the destination, did I send an email to them before? If I did, then they're legit. There's no question, so they'll let everything through. If I haven't, well, then we start being a little more suspicious. Apply these filters. So then it tends to be pretty good. Depends. But at least spam has gone down quite a bit. And then what about, let's see, authentication. So as we've noticed, this isn't going as well. Right? We can still send stuff from whitehouse.gov, but I think that what's in place is more of a soft authentication, so it affects the spam filters. Like if someone can prove that they are from the White House, then this email will go through, more likely to go through, even if it has a bunch of suspicious keywords about Russian real estate in the email. Whereas if you can't prove your origin, then it'll just get thrown out. Okay, so there's a couple of ways to do this that are common. One is called the Sender Framework, Sender Policy Framework. This one is relatively commonplace. So the idea is, you send an email, you say I'm from whitehouse.gov, but before the destination server accepts the email, like in this case, before UIC accepts the email, they will go and ask whitehouse.gov to see, is this person actually authorized to send email on your behalf? So how can we check that? They can't check persons because there's no password here. But one thing they can check is the IP address. So they can say, is this email server allowed to send email on behalf of the White House? So we can check this. Let's see. Yep, there it is. All right, so the White House actually has, I didn't check this before, but it looks like, I don't know what this Mandrill app is, but they do have a restriction. This is under policy. This is a policy for the whitehouse.gov domain saying if you're going to be sending email with this domain as origin, your IP has to be in one of these address ranges. So that's pretty good. Now, unfortunately, UIC doesn't enforce it. So UIC doesn't go and check, or at least the CS server. I don't know. I haven't checked all of it, but that doesn't either. Okay, yeah. But it could be that they do check it, and then they mark it as, well, this one probably isn't all that authentic, right?
Yeah.
It's hard to tell exactly what's going on.
Gives you that message. It says like this was only not marked because of your organization settings.
Okay, I see. Yeah, so anyway, this actually tells these servers are allowed, these addresses, which are very difficult to fake, are allowed to send email on the behalf of the White House. Yet another one, and I don't have a good example, I think, but it'll look something like this. So Dig is a DNS client. It's just querying this enormous lookup table for various entries given a certain domain. We'll talk more about that later, but here's something similar looking. It's not right though. So the other approach is when you send an email, you include a signature in the email, a cryptographic signature, saying basically, well, we haven't talked about cryptography much, but basically it's a unique signature for this exact email, and then with a digital signature that's based on some secret that only I know. And you can prove that it was me that signed the email by looking up in the DNS record. And I didn't manage to figure out how to look it up, but it'll look much like this. Here's a key, a public key for Google for global sign. That's something slightly different. But basically, if I use this thing, it's a mathematical operation, I can figure out that the signature that came with the email is actually legit. So only whoever has the secret for the signature can sign it properly, and I know this was sent by Google. We'll have to talk about cryptographic signatures maybe next time even, just to see kind of roughly how it works. The math behind it can get extremely complicated for the proofs, but just the doing it math is really simple, so we can do that. Okay, so anyway, there's email. That's pretty much the state of it today. These things are kind of in place here and there, and kind of a patchwork, but most of it is just a bit of a Wild West still. Okay, I'll see you on Friday, and don't forget about the homework.